Hi folks, I'm back again with another video to showcase what 𝐻�XAView is doing in AI. In my last video, I shared how 𝐻�XAView created a web application using vibe coding for legacy app modernization. In that video, I showcased a platform where we converted legacy code into modern language. Today, I'm going to use 𝐻�XAView's AI-first engineering approach to develop an enterprise-grade, production-ready order management system, not in months, but in weeks. How did 𝐻�XAView achieve that? 𝐻�XAView has come up with its own platform called Haki AI, which is 𝐻�XAView's AI knowledge integrator. Haki in Japanese means ambition, and 𝐻�XAView is ambitious to utilize AI to develop production-ready applications and not just vibe code for demos. So today I'm going to share a use case of TOMS. It is called a trade and order management system. A system where billions of dollars are traded every month. 𝐻�XAView has created many trade and order management systems in the last 15 years. A trade and order management system is utilized by financial advisors to create portfolios, to manage them, to rebalance them against models or targets for order generation and for trading. In our experience from a traditional agile methodology, any such platform is a big platform and usually takes 4 to 5 years to not only to build it but to maintain and regularly upgrade it. We have an ambition to actually attain a similar level of product with exactly same quality in 8 months using 𝐻�XAView's Haki AI framework. How did we achieve that? I'm happy to share that we did achieve the phase 1 of the application in 4 weeks, where we created multiple modules like accounts, positions, but the most important logical module is the rebalancer, which we created in 4 weeks with 100% accuracy. It is deployed, production ready, and utilized by customers. So the question is, how did we do that? We are all aware of Agile SDLC, right? We just modified that SDLC and now calling it AI-enabled software development lifecycle. This lifecycle will follow the same methodology, but compresses the entire cycle by about 7x to 10x. How did we achieve that? Yes, we used a lot of prompt engineering in order to reach to our desired outcome. But rather than just directly jumping into the code, we actually used a very process-oriented approach where we thought that what will be our baseline, what will be the benchmark which will be utilized in order to make sure that every time we generate the code, it is in adherence and compliance with the customer requirements. So our very first phase, as we all start in Agile, is the requirement document. We call it specifications or PRD. From the PRD, we just auto-generate UAT, which is the user acceptance test cases, a very important parameter to ensure that it meets the criteria 100% what customer has laid out. From there, we created user stories, wireframes, HDDs, LDDs, all through prompt coding, all through prompt engineering. Now, once that baseline has been set up, we actually coded using Cursor. So our main development environment was Cursor. We utilized Cloud Code as well in order to write code. That is where my development box comes into picture here in the slide, where our AI pod and AI engineers, they did a lot of coding using Cloud and Cursor. And we utilized Git for storing the repository, for storing our source files. On the testing front also, we used a lot of tools. One of them is Karate Labs in order to automate API testing, functional testing, integration testing. And we also integrated with our project management tool which is Jira, in order for tagging the test cases, creating user stories, everything using MCP protocol. So we did that as well as part of our project. Now we integrated test cases using GitHub Actions into our repository. We also created production ready deployment architecture with the CI/CD pipeline, again all using prompt engineering. The only difference that comes from vibe coding between vibe coding and what 𝐬𝐴𝐸 AI enabled SDLC brings in is the human in the loop. Every step, every process, we had a review by our engineers, by our product orchestrator to ensure that it is complete, it follows the standards, and it is in compliance with the regulatory standards of a trade and order management system. Now, how did we achieve that? Because again, this whole manual process could be quite cumbersome. Before we move there, I want to share what an AI pod in 𝐬𝐴𝐸 looks like. In general, I mentioned building a trade and order management system could be a 20 people team. We did it with 5 engineers. We did it with actually 4 engineers and AI agents. All our engineers, we call them AI engineers, which can play a role of developers, testers, operational ops navigator, which is like DevOps, and systems architect, which is like a solution architect in a traditional role. There was a team of 3 engineers, AI engineers, which were playing these roles. And on top of it, we had a product orchestrator, which in traditional language, in traditional world, we call project manager. Now this product orchestrator was actually playing the role of a BA, was doing user testing, was taking care of stakeholder management, was doing the project management, which is KPIs, measuring and maintaining, all using AI. Apart from that, the most important part here is, which actually compressed the entire SDLC, are the AI agents. So we used very standard, well-known tools like Cursor and Cloud Code in order to generate a production-ready enterprise application. Before we actually deep dive into the code that we created, the documents that we generated, I want to show you the output. How the AI engineered application looks like as compared to the traditional one. The screen that I'm showing you right now, it's a sample dashboard between a traditional application and AI engineered trade and order management system. The functionality is absolutely same, but the UI is more modern in the new AI engineered application. Similarly, another screen where we do sleeve rebalancing, and there also, if you see the older application and how the new AI engineered application looks like, which is much more modern. I would also like to share the project timelines with you, what we followed in order to create an AI trade and order management system. We started the phase 1 from May 19th, where we reimagined how the OMS will be created through AI tools. In the very first week, the initial hurdles we actually resolved, especially the fear of using AI tools, how we will use those tools to produce a production-ready application, and getting our hands dirty, trying out various things. After that, we actually divided the entire application into modules, where I mentioned the separation of concerns. We followed microservices architecture, and based on that, every module is a microservice. In the very first week, we developed security and security type. Then we went to sleeves. Then we went to models, accounts, and the most complex one is the rebalancing. We completed these applications, all these modules, by around 10th of June. And then we integrated them, deployed them by around June 13th. Then in the next 1 week, we AI tested it using a lot of AI tools like Karate and prompt engineering. And in the same course, we did a lot of bug fixing to make sure that only the relevant piece of code is changed without changing the subsequent parts. That is something that I'll cover in my second video on the same project related to vibe maintenance. What if an application is created using vibe coding? How will you maintain it? How will you make sure your bug fixes are localized rather than generalized? Which I'll cover in the next video. Coming back, we released the entire phase 1 by June 20th. Let me share with you the challenges that we faced during the duration of this project. The first challenge is coding precision. Whenever we were implementing something new, it was affecting the older modules, which means we need to train our prompts to be accurate, to be localized rather than generalized. The second portion was in traditional agile methodology, it seems very seamless to go from development to deployment. Whereas in our AI-enabled SDLC, it was challenging. Using these environments, Lovable, Replit, cursors, we tried multiple of them and then finally zeroed down on cursor. They offer a lot of end-to-end capabilities, but doesn't give you a true seamless flow between development, testing and deployment. They are still feels disjoint. They still feel separated. So we really need to work to create a pipeline to bring them together. The third one is refactoring frequency. As I mentioned, using these tools, it is very easy to reiterate the code again and again. Over a period of time, we understood how to reduce the refactoring frequency, which means when we start coding, we have to make sure that it follows the standards. It follows the rules that we gave. That is where a lot of our documentation came into picture. That has been a learning. The fourth point is about code reviews, right? We did peer code reviews, but then when the integration happened between different modules, then the code reviews were overlooked. Because of that, there was certain deviations from our standard architectural guidelines, which were identified and resolved later. The last but not the least is the design divergence. Over a period of time, when we reiterated or regenerated code again and again, we found that the application, the user interface, the functionality started deviating from the original specification document. The tools like Cursor, they struggled to be effective in persona-based prompts, which is a tester prompt, a developer prompt. The disconnect started happening between your HDD and your actual code. So that's another learning that we understood, and we filled those gaps so that the HDD, the code, it replicates the original specification document. We started with certain goals in mind, certain KPIs in mind. Some of them we achieved, some of them we plan to achieve as we move to next phases. So we started with a KPI that we'll do 90% of AI assistance code. We actually attained that. We were able to generate 90% of the code accurately with our AI-enabled SDLC. The second is the code review efficiency. We would like to reduce the code review time up to 75%. We are right now at around 50%, and we're going to increase it in next subsequent phases. Then the automated tested coverage using the prompt engineering. So what is the amount of test that we generated? So we attain, or we at least aim for 100% automated test coverage. We were there at 90%, where in terms of the boundary analysis, in terms of completeness, where a human in the loop actually reviewed it and made it better. And at the end of 4 weeks, we were at 100% coverage. In terms of lines of code, to give you an example where we stand, how much lines of code we generated in 4 weeks, we generated around 62 lines of code, 62,000 lines of code in around 548 files. Remember, this is not one iteration, but multiple iterations. But the best part is, it is a production-ready application. It is a deployed application. It is an application that whether we can maintain, tomorrow if any bugs comes, we can actually fix it without really affecting the entire functionality. So in the end, really, how much time did we reduce? We actually attained a 7x efficiency, or we actually reduced the time by 7x. Now I will take you inside the kitchen. What kind of documents, what kind of artifacts did we generate while creating this enterprise-ready, production-ready application? So we use SharePoint in order to store all the documents that we have. Right now what I am showing you is some of the PRDs or specification documents that we created. We had an accounts document, we had a sleeves document, rebalancer, security master. Let me show you an accounts document. Right? This is how an accounts document was generated. What is the purpose? What is the scope? What is the functionality? How many sections will it have? All that was mentioned. Similarly for sleeves, we actually went on to create a PRD for the sleeve module, how the sleeves will function, what are the definitions of various attributes inside those sleeves, what are the various sections, everything was gone through. Similarly, we had certain documents at the platform level. So to give you an insight, we generated two types of documentation. One at the application level and one at every module level. At the application level, we wanted to share what is the vision of an order management system. We want to share what are the best practices that we have followed traditionally in the last 15 years for the front-end application, for the back-end rules that we follow. So these are the design goals, these are the folder structures that we wanted, these are the naming conventions, what kind of technology framework we want to use. We created all that. Apart from the specification documents, we also created technical design documents. We have an account technical design document. We also created .NET rules that we follow generally in traditional deployment. The point is, these certain documentations, as I mentioned, are at the project, at the application level, and some are at the module level. .NET development rules, global guidelines, right? Security, observability are at the platform level. Account technical TDD is actually at a module level. So let me show you at the module level. This is how a module level documentation looks like, where we generated user stories, where we generated functional flows, where we also generated database designs, table designs, attributes inside it. I'll show you the attributes here in the sleeve management system, the sleeve management module, where we have the fields, where we have the tables. Not only that, we also had APIs that we want to expose for the front end to consume. This is a sample .NET, very simple, high level, what kind of .NET framework, syntax we follow. Now, I also want to talk about a very interesting fact or a difference between traditional engineering and AI-enabled engineering. Till now, everyone always thought that code is the prized possession of any application. Code is the real IP of any software application, whether it's a product company, whether it's a big enterprise, whether it's a consulting company. Everyone thought code is the IP. But with AI-enabled engineering, code is auto-generated. Hundreds and thousands of lines of code can be generated by a click of a button. So now, in this new world, what is the real IP? The real IP are the prompts that ensure that the code that is generated follows the standards. Code that is generated follows the compliances set across in the industry. It is the same set of prompts that we give will always generate almost similar code. So the new IP in an AI-enabled engineering world are the prompts and the documents and other artifacts that we generate and we give with the prompts to generate the code. So HexaView has come up with its own internal library called HexaFlow. Now HexaFlow is just a web platform that again we generated using AI, which stores all our prompts, whether it is engineering, development prompts, whether it is test prompts, whether it is BA that uses the prompts, whether it is deployment prompts, as well as all the artifacts that I showed you, the .NET development rules, the global guidelines, the observability guidelines, the security guidelines, everything is stored in an internal repository which we call HexaFlow. So I'm going to show you a sample prompt that we have used for the backend in order to generate a security and security type. These are big prompts, as we can all understand, because they do a lot of stuff in one go. You just give this prompt on cursor and just wait for magic to happen. Similarly, I have prompts for this was a backend prompt. I have prompt for the UI, the UX that is generated. As you can see, this is like a 35-page document, and this is just a sample of prompts that we have utilized. We have utilized hundreds of prompts to reach to a level to generate a production-ready enterprise application. So this is a sample prompt. Simple, what is the system design prompt? What kind of data access do we want to get, right? What kind of relationships do we want to maintain? That's how we have actually given a lot of prompts, which also sometimes has some parts of our algorithms, our thought process, modules or interfaces that we talk about. Now let me show you how our cursor environment look like. We have created multiple repositories. This is my UI repository, 𝐻𝐿TOMS UI, which has various sections, various modules on the UI side. And we also have cursor rules. So I'm showing you a sample cursor rules that we have created to follow certain guidelines and standards to generate an enterprise production ready application. On the right hand side, I have a sample prompt that I would like to run and show it to you. For example, we have something called neglected accounts, right? And we want to show a different color if the number of neglected accounts is greater than 50%. So let me click on run this prompt and it will automatically go and generate and run the prompt. Not only that, while running the prompt, it will also highlight the sections of the code that it actually modifies. And it gives me an option where I can accept or reject certain sections of code. Anything that is added by a cursor, it is in green. Anything that is removed is in red. And I have the choice to accept or reject. For example, when this whole thing is run, as you can see, it shows one file edited. There are 2 additions and 3 subtractions. If I click on it, I see all the additions and subtractions that has happened over the code. And every addition and subtraction I can either accept or reject. That is how we have done the coding, and sometimes we have also utilized it for bug fixing. Now if I run this application on my local, I would like to see and I could show if I can show you how this application looks. Now the running application, as I clicked on run the application on my cursor, it is actually running the application. That's how easy it is to check what you have created. The first screen that you are seeing here is the dashboard, where I see a glimpse of the entire application. How many accounts do I have opened? How many pending orders are there? What are my investment or target models? How much cash is available? How many buy orders and sell orders are pending, are completed? What has been my number of orders? How many orders have generated over a period of time? My pending orders and whatnot. So everything is available. If I go to account section, I have a list of all the accounts or the portfolios that are available, and I can search for an account. If I click on that account, I can see the various attributes, the cash as well as the rebalance, which is where the real magic is, the real logic is, where the account has to be rebalanced against a model, and this rebalance has to be accurate. The orders, the quantity, the total market value has to be accurate in the application, and we were able to achieve it using AI-enabled engineering. So let me click on this, let me generate orders. This will actually generate a lot of orders, and I can see all the orders that are generated, buy orders, sell orders. I can even select them and fill these orders if I want. Similarly, I have security master, where I have the list of all the securities that I want to see. For example, American International Group, is it tradable, the basic modules of the security. Every security is of a particular type, so we have security types. Similarly, we have models. A model is a target model against which a portfolio is rebalanced. Now all these models have sleeves in it. I can have multiple sleeves, single sleeves. Every sleeve has an allocation. I can get all that. Under models we have sleeves, so I can go to sleeves also, and I can see the various sleeves available in the system. Similarly, I can have administration section, user management, global settings, audit logs, which is very important in finance, who did what and when, and similarly profile settings. So it's a complete application, it's a complete module that we generated in 4 weeks and being utilized by our customers. In the end, I would like to say that we just didn't build a 𝐻𝐿TOMS component. We actually rewrote how enterprise software can be built using AI first engineering. Thank you.